Hi everybody, welcome to part 2 in lesson 3, and this problem is titled 2, Expanding Squares. Okay, so now it might be a good time to talk about the 3 lesson goals for this lesson. They're right up there. The first one is that I can recognize quadratic functions written in different ways. So we have to talk about quadratic functions. And if we don't know what that is, we should make sure we do know what that is by the end of probably this problem. And 2, we want to focus on writing them in different ways. Okay. The second goal, I can use information from a pattern of shapes to write a quadratic function. So pattern of shapes are the patterns right there. This is a pattern of shapes. We call them pile patterns or tile patterns, but those are the shapes we're talking about. And apparently we're going to use them to write a quadratic function. Number 3. I know that in a pattern of shapes, the step number is the input and the number of squares is the output. So input and output are are very like function type words, but essentially what we want that to mean is we want to realize that the step number is going to be used to figure out the number of squares. That's the idea, right? If I input the step number, can I output the number of squares in each step? This also tells you what you should think is important when you're looking at pile patterns, right? What's important? The step number and the number of squares or tiles, right? So when we're looking at these pile patterns, that's what we're trying to connect. That's what we're trying to notice, is how does the step number show up in these pile patterns and how does the total number of squares show up in these pile patterns. Okay, so we've got these piles, or these steps here, step 1, step 2, step 3. And I'm going to say, go ahead and read through number 1 and number 2 and number 3 and try and figure out number 1 on your own. So I'm going to be copying down the squares, but if you need longer than that, pause the video and work it out on your own. Once you're done with number 1, unpause it and we'll talk about it together. So I'm just going to be copying squares. You can either pause or jump ahead if you're ready to talk about the problem number 1. Step 1. It's got this flowery looking thing. And I've got this nice grid paper, but I'm honestly not that concerned. Step 1, about making it look all that neat. Maybe I should be. Okay, step 2. Kind of almost has this like pixel Mickey Mouse thing going on until I've got to write this. Maybe Frogger. Did you guys ever play Frogger? Little frog. And step number 3 is getting even bigger. Kind of running out of space here. I think this will work. Okay. And even in drawing these, you might start to notice, like, you kind of are counting the squares just to figure out like how big to do it, right? So because I have grid paper, I'm noticing a few things. So let me kind of fill in the details here. Scoop. And I'll talk about what I notice in a minute, but no spoilers now. Step 3. Oh, I'm already noticing this isn't step 3. This is step 2. Okay, step 1, step 2, step 3. Okay, number 1. If the pattern continues, what will we see in step 5 and step 18? Sketch or describe the figure in each of these steps. How many small squares are in each step? Explain how you know. Okay, so if you haven't already, pause the video to see if you can answer those 2 problems on your own. and then when you unpause it, we'll come back and we'll talk about what I notice and how I describe these, and you can see how that compares to what you noticed. Okay, so pause the video and we'll be right back. Okay, everybody, welcome back. So, if the pattern continues, what will we see? So I think most of all, like, do you see a pattern, right? And so from vague to specific, yes, I see a pattern. The shape looks basically the same, except it seems to be growing, or at least the middle seems to be growing. So 1A, sketch or describe the figure in each of these steps. So step 5 will look basically like this, right? It'll be like a square doodad thing here. It'll be a bigger square doodad thing here. And there, step 5, sketched, right? Could I be more specific? Absolutely. Step 18. Well, it's gonna look basically like step 5, except even bigger. So it's gonna be like this really big body here. And it's gonna still have these little squares in the corner, but I've drawn them kind of smaller because they're gonna be smaller relative to like the big area in the middle. So sketch or describe, there you go. I sketched or described it. Should I be more specific? Probably. So let's get more specific in part B. So part B says how many small squares are in each of these steps. Okay, there are going to be so many ways to do this, and I don't want anyone to get the impression that there are better or worse ways to do this. With that said, I am going to remind us about the lesson goals for today, which are all about knowing that number 3, in a pattern of shapes, the step number is the input and the number of squares is the output, which means we are going to try and see if we can find a connection, just a connection, between the step number and something about the total number of squares. Or maybe the step number and how the shapes are changing. So let's do some annotating. Going all the way back to step number 1. Let's start with the black pen. One thing I notice in every single step are the 4 arms or legs or wings in each of the corner. Right, so these seem to be always there. Right, always, always there. Is this tedious? Yes, it is a little boring. But we're all trapped inside anyway, so whatever. But like this really hammers home, like, oh right, in every single one of these steps, there's always going to be these 4 little corners, right? So in step 5, I know there's going to be these 4 little corners. And even in step 18, I know there's going to be these 4 little corners. Okay. So what about everything that's not the corners? Well, let's take a look. In step 1, there's this, let's do this in red so it really pops. There's this 1 square in the middle. Right? In step 2, there's 1, 2, 3, 4 squares in the middle, which means we can say that this middle shape is 2 across and 2 up. Did you see that? So this middle shape is 2 by 2, the same way this one has a center that's like 1 by 1. A pattern maybe. Do you see the same thing happening in step 3? Yeah. Once we count it out, we say, oh, aha, look. Step 3 has this middle part that has squares going 3 across and squares going 3 up. Now, maybe you noticed that, maybe you didn't. Maybe you noticed that and didn't know how to describe it, or maybe you noticed it and you weren't sure whether or not that was an important detail. If you see it now, I think you're doing the right thing. So whether or not you've seen it already, let's see if we can use it to go on. So let me make something even more clear. So this was step 1, and the middle part was 1 by 1. This was step 2, and the middle part was 2 by 2. In step 3, the middle part was 3 by 3. So here in step 5, what do you think is going to happen in this middle rectangle right here? Well, maybe it's going to be 5 across and 5 down. If I were to fill it in, 2, 3, 5. Maybe something like that. Seem reasonable? Does it fit with the pattern here? Step 1, 1 by 1, step 2, 2 by 2, step 3, 3 by 3, step 5, maybe there's a 5 by 5 here. Which means, step 18, this is probably going to be a big square. That is 18 across and 18 down. Am I going to try and draw this? Ooh, it's going to get really messy. 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 14, 15, 16, 17, 8, ugh. 1, 2, 3, 4, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. I'm sure I messed up counting in there somewhere. But obviously, like, making all these squares isn't a good way to do this. So this is really like, oh, well, I really know it's going to be 18 across, even if I miscounted in the middle. Okay, so B says specifically how many squares in each step. Well, let's do this in an organized mathematical fashion, which means make a table. So we're going to make a table going across just because of the space I've got. And we're going to say step number and number of squares. So in step number 1, the total number of squares is easy to count, 1, 2, 3, 4, 5, but I'm going to count it in a very specific way. I'm going to say 1 plus 1, 2, 3, 4, right? So I know the total is 5. I know you know the total is 5. But I'm going to write it in a way to remind us of our pattern. Because in step 2, 1, 2, 3, 4, or 2 times 2, right? So there were 4, and then the 4 arms on the outside, right? So this is going to be plus 4. In step 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then plus 1, 2, 3, 4 on the outside. Okay, now jumping to step 5. So step 5 is going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 of the red squares on the inside. Plus. All right, 18. can we all agree that you don't want me to count all these little squares? Please? So can we think of a different way to get the number of squares in here that doesn't require me to count? Right? Maybe using the pattern we've noticed here. Maybe thinking about how we find the area of a big square in general. We can see that to get the total number of these red squares should just be 18 across times 18 down, or 18 squared. So I can do 18 times, oops, let's clear this. 18 times 18, which is 324. Or just because I said it, we could do 18 squared with the little 2 up there, same thing, 324. So the red squares, there are 324 red squares, and 1, 2, 3, 4 little black squares on the corner. And yes, my sizing is off here, sorry. So then maybe we can fill in the table. This 1 plus 4 is 5, 4 plus 4 is 8, 9 plus 4 is 13, 25 plus 4 is 29, and 324 plus 4 is 328. So B asked to tell them how many small squares are in each of these steps and to explain how you knew. And I would say, I've explained. I've color-coded where I'm getting these results from, and I've broken down the 5, 8, 13, 29, and 328 into where I'm counting that from. Could I add more detail here? Probably. I could go back and I could say, oh, by the way, I got 324 by doing 18 squared. That would be a little bit better. But if you don't have that, it's fine. Okay, let's go on to number 2. So if you haven't done number 2 yet, then pause the video, read it, do it on your own, and come back and we'll go over it together. Okay, welcome back. So number 2 says, write an equation to represent the relationship between the step number n and the number of squares y. Be prepared to explain how each part of your equation relates to the pattern. If you get stuck, try making a table. We already made a table, so great. We'll just have to augment it based on their new directions. So let's scroll up a little bit. So number 2. So it seems like we can maybe start by making basically the same table as before, but I'm going to change it in 2 ways. One, we're going to use their letters. So they say use the step number n and call the number of squares y. Why do they do n and y? Why not s and t or x and y? Who knows? Those sound like fine options to me, but they want us to use n and y, so let's use n and y. So the step numbers are still the same, right? 1, 2, 3, 5, 18. And now here I'm going to repeat the n because this spot right here is where we're going to try and build a rule. So can we build a rule based on what we've noticed already? Just to recap, the rule is, or the pattern we found for the first one was to say 1 plus 4. And then for step 2, it was 4 plus 4. For step 3, it was 9 plus 4. For step 5, it was 25 plus 4. And for step 18, it was 324 plus 4. And remember, where did all these red numbers come from? Well, 324 came from 18 squared. 25 should look familiar. That's 5 squared. 9 is 3 squared. 4 is 2 squared. And 1, technically 1 is 1 squared. We don't think about that very often, but 1 squared is still just like that 1 by 1 square, right? 1 square is still 1 squared. So remember, goal number 3, I know that the step number is the input and the number of squares is the output. Do you guys see the step number being used in each of these? Right? Here's the 1 and it's 1 squared, the 2 and the 2 squared, 3 and the 3 squared, 5 and the 5 squared, 18 and the 18 squared. So in the nth step here, we say, well, it always seems to be that you take the step number and you square it. N squared. But that's not all, because then there's always this plus 4 at the end. And so when they say, write an equation to represent the relationship between the step number and the number of squares, what we have here is the core part of this relationship. What we have here, technically, this is an expression because there's no equal sign. So the answer to number 2, the actual answer is going to say, let's see, let's do this in, let's do it like this, is going to say y equals n squared plus 4. And that is our formula, or our equation. And you should go back and make sure you understand where each of these parts come from, right? The n squared comes from the size of the middle in our pattern, and the plus 4 comes from the 4 feet on the outside. And so that is number 2. Number 3, sketch the first 3 steps of a pattern that can be represented by the equation y equals n minus 1. All right, if you haven't done this already, pause the video and see if you can create a pattern that matches y equals n squared minus 1. Okay, welcome back. I just remembered, we're not going to do this in this video because it's getting long, but the formula that we came up with for this pattern is not the only way to do this. I'm looking at learning lesson goal number 1 up there. I can recognize quadratic functions written in different ways. So there is more than one way to do this. And maybe in a follow-up live stream, we will go over a different way to think about this. But if you think you've got a different way, good for you. And I'm sorry I didn't say that sooner. This is definitely going to come up, though, I think, in number 3. Sketch the first 3 steps of a pattern that can be represented by the equation y equals n squared minus 1. Well, so there are lots of patterns that can do this. So whatever you do is probably fine. The minus 1, though, I think is going to be a little bit tricky. So the n squared part this should remind you of what we did up here. N squared means there's going to be a pattern of growing squares. Right, so there's going to be a pattern where in step 1 there's going to be 1 square. In step 2 there's going to be 2 squares. Oop, let's scroll over. And in, or sorry, a 2 by 2 square. And in step 3 there should be a 3 by 3 square. So this would be the n squared pattern, right? Each step just has one bigger square. 1 by 1, 2 by 2, and in step 3, 3 by 3. But wait, you might say. I thought there's supposed to be a -1 in here as well. So just like in the previous pattern, the +4 meant we had these like little feet. -1 means we somehow need to have negative feet. So how do we have negative feet? Or maybe -1 just means, in a more basic sense, take away 1. Right? So step 1 would be a 1 by 1 square, but you have to take 1 away. So step 1 would actually just be nothing. Step 2 would be a 2 by 2 square, but you'd have to take 1 away. So I can take this square and just like remove it, pretend it's not there. So the actual shape is just like the L here. Something like that. A 3 by 3 shape, same thing. We could take the same corner and just like remove it. So the actual shape would be this more differenter L shape here. Right, so that -1 means we see a square, but we're taking out a bite of the corner. Like I said, this is not the only way to do this, and there are many other ways to get much more creative about what this might look like. But this is one way. If you want to talk about different ways, maybe that's a question to keep up for later. So this is the end of problem number 2. We have one more problem in lesson 3, which will be in the next video.